Hello, my little mathematicians. Today we're going to go through the Mod 9 through 10.2 study guide. As always, feel free to pause the video, try it yourself, and then unpause it to check yourself. Okay, the first one, 5 squared is not 5 times 2, but 5 times itself 2 times. The exponent tells you how many times to multiply your base times itself. So 5 times itself twice, 5 times 5 is 25. Okay. The next one, anything to the 0 power is 1, okay? And if for some reason you're struggling with that, try it this way. 7, let's try it with an easier number. Let's do 2 squared, 2 to the 3rd, and 2 to the 4th. Okay, if you were to multiply 2 times 2, you'd get 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. Okay, and then 2 to the 1st power is just 2. There's only 1 2. Notice how each time you move up, what are you doing? You're multiplying by the base, right? So each time I go up an exponent, I'm multiplying by another base again. So 2 times 2 gives me 4. 4 times 2 gives me 8. 8 times 2 gives me 16. So if each time you go up another exponent, you're multiplying, when you go back a step, you would be dividing, right? 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1, which means this one, 2 to the 0 power, is 1. And that pattern continues whether it's right here with a base of 3 or 4 or 5. So 3 to the 3rd power, 3 times 3 times 3 is 27. 3 times 3 is 9. 3 to the 1st power is just 3. Each time you move up, you're multiplying by another 3. Go back a step, 27 divided by 3 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. So anything to the 0 power is 1. Just remember that, but at the same time, that's why that works. All right, let's move on. 2 to the 4th power, you have 2 times itself 4 times. So let's group those together. 2 times 2 is 4. That 2 times 2 is 4. And 4 times 4 is 16. Or you already did 2 to the 3rd over here. And that was 8. So one more of them would have been 16. Okay. And then 12 to the 1st power, you have 12 times itself, just 1. So 1 12. There you go. The next one says write in exponential form. Okay. So that means that you're going to write your base and represent it using an exponent to represent how many 8s you see. 1, 2, 3, 4 8s. So it's 8 to the 4th power. This one is 2/3. And there's 2 of them, right? So 2/3 to the 2nd power. Now that looks right, but it's actually not right. Because what this is showing right now is a 2 times 2 on top and just 1 3. And that's not what I want. I want the whole thing of 2/3 times another 2/3. So I need to make it clear that it's not just the 2 that's being squared, but the entire thing. So yes, parentheses matter. With the parentheses, it's this. Without the parentheses, it's this. And that is not what this is saying. So please make sure to include the parentheses when you're multiplying a whole thing times a whole thing, right? That whole thing times itself twice. This one is saying the product of a number and 5. So product means multiply, right? And a number, we don't know what that number represents, so we could use any letter to represent it. I'm going to use an X and 5. That is technically acceptable. We prefer you to just delete the dot and just write 5x. We like the number in front of the variable. Please do not in any way do this anymore. Okay, we do not use an x to represent it because that looks like 5 times some number times that same number again. So x times x is x squared. So it's 5x squared. No, it's not. It's 5x. So we are not going to use that to represent it anymore. These 2 ways are acceptable. This is the preferred way. Okay, the sum means plus, of y and 12. So after the word and goes the other number on the other side of the plus sign. Okay, the quotient means divide. 7, so that goes on top. And so on the other side, the division sign goes a K. And of course, you also could have written it as 7 divided by K, as long as 7 comes first because it came first there. The next one says the difference, so subtracting, of a number. We don't know what that number is, so I'm going to use an X, but you could use any letter because it didn't specify what letter to use. And 19, so after the minus sign comes the 19, multiplied by 8. So that means it's this whole thing multiplied by 8. So let's put that whole thing in parentheses because it's that whole difference multiplied by 8. 8 less than, okay, now if it just said 8 less E, it would look like this. But because it says 8 less than, the than moves it to the back. Okay, so it's minus 8. Because think about it, you're taking 8 less than what? 8 less than E. So that is the correct one for this problem. Whenever you see a than or a from, that moves that letter to the back. Okay, so if it's like less than, fewer than, subtracted from, then it moves that letter to the back. It would look like this if it said 8 minus E, or the difference of 8 and E. Then the order doesn't change and it's just like this, okay? But if you see the word than or from, it moves it to the back. The next one says the sum, so sum means plus, of 4 and y. So y goes in the back, multiplied by 10. Okay, now this is tricky. Is it this again? Or is it the y multiplied by just the 10? Well, notice here that there was a comma. So it's saying this whole thing is multiplied by 8, which is not what this is saying. This is saying the sum of 4 and y is being multiplied by 10. So it's the sum of basically 4 and 10y. 10 is not being multiplied by the whole thing. 10 is only being multiplied by the y. So do commas make a difference? Actually, yes, they do. All right, the next one says the difference. So difference means subtract. The difference of what? 4. And, okay, so on the other side of my minus sign is x split evenly into 5 groups. So that means it's x split up into 5 groups. There you go. Okay, or you could have written it as 4 minus x divided by 5, because isn't this saying x divided by 5? Because when you split up something evenly, that's dividing it up. Either one of these are acceptable. They're both saying the same thing. Okay, 2 subtracted from, so that moves the 2 to the back. 2 subtracted from what? The product, so I'm going to multiply something. I'm multiplying 5 and w. If you're getting all these right, congratulations. But again, remember, be pausing the video and trying things yourself first, and then unpausing to check yourself. Okay, this one says, Johnny and Tim go swimming each week. Tim always swims 5 laps less than Johnny. So less than moves it to the back. So I'm going to subtract 5 from Johnny. Now, how does it want me to define the variable? Because sometimes this might change this. But it's saying it wants you to write an algebraic expression to express how many laps Tim swims. So Tim is equal to whatever Johnny is minus 5. So that makes sense. Yes. So the algebraic expression is j minus 5. And that will give you Tim. And then it says to define your variable. So what is j representing? J is telling you how many laps Johnny swims each week. So if they ever say to define your variable, you're telling them what does it stand for? What is it representing? J represents how many laps Johnny swims. Okay, the next one saying Sarah's organizing her socks. She has one big pile of socks and wants to divide it into 4 smaller piles. So I want to divide it into 4 small piles. Write an algebraic expression to express how many socks are in each pile, then define your variable. So you take, we don't know how many socks are in that big pile, but I'm going to divide it up into 4 groups. So that is my expression. Or of course, S divided by 4 would have worked as well. And then S is representing the total number of socks, because you take the total number of socks and then divide it into 4 piles. And that's going to represent how many are in each little pile. All right. Go ahead and try similar problems to the ones that you missed if you find any in the notes or homework throughout the week or extra practice. And then don't forget to star ones and ask next time in class. All right. This one, pretty tricky looking. Let's first of all focus on getting the numerator to one singular thing. So I'm going to focus on just the numerator first to get one single number. So 12 divided by 4 plus 10 times 3 minus 3 squared. First thing you do is I'm going to, the smart choice to be, put over 8, and I'm going to kind of draw an arrow going up so that I don't forget. Whatever answer I get after doing this big long problem is going to go here on top of divided by 8, because after you're done doing this huge long problem, you might forget that that was even there, because right now I'm just simplifying the top. Okay, order of operations, or PEMDAS, still applies. So you guessed it, parentheses first, 10 times 3 is 30, minus 3 squared, plus 4 divided by 12. Okay, parentheses are down to a single number. Do you see any exponents? Right here, what's 3 squared? 9, because it's 3 times 3. Not 3 times 2, but 3 times 3. Okay, parentheses are down to a single number. Exponents are simplified. Do you see any multiplication or division? Right here. 12 divided by 4 is 3. And then now we only have addition and subtraction, so you go from left to right of whichever one comes first. 30 plus 3 is 33 minus 9. And let's not be ashamed to work that off out to the side so we don't miss it. 13 minus 9 is 4. 2 minus nothing is 2. So that simplifies to 24. Now that's not your final answer, but you might have been tempted to think it was. And that's why I suggest drawing your arrow up here to be like, hey, that just represents the number on top. You still got to divide it by 8. So your final answer is actually 3. Okay, the next one. Do you see any parentheses? No. Do you see any exponents? No. Do you see any multiplication or division? Yes. Which one do you do first? This one, because you want to go from left to right, right? So this first before multiplying, when deciding between multiplying or dividing. 24 divided by 8 is 3. Bring the other stuff down. Okay, do you see any more multiplication or division? Yes. 3 times 4 is 12. Bring your other things you haven't simplified yet down. And I forgot, we actually changed this to a 40 for that specific reason. Sorry, I didn't print the new copy. Because you can't take 12 from 7, can you? All right, so now it said 40 minus 3 times 4 and 40 minus 12. Okay, now you can go 40 minus 12. And 10 minus 2 is 8. 3 minus 1 is 2. So that simplifies to 28. Bring down your plus 6. And 28 plus 6 is 34. Okay, the next one. Do you see any parentheses? Yes. Right here. Inside the parentheses, order of operations still applies. So do division before subtracting. And 6 divided by 2 is 3. Okay, and then we still need to simplify the parentheses. 17 minus 3 is 14. Okay, and then you have 4 times 3, which is 12. And 14 plus 12 is 36. right? Is that what you got? You didn't. Why? Because was I going too fast? So right here, 4 plus 2 is 6, and 1 and 1 make 2. I don't know why I carried that 1 right there. So hopefully you got 26. Okay, and don't be ashamed to, when you check an answer key, go back and check your work and see if you made a mistake somewhere and challenge the teacher. Okay, sometimes I do mistakes on purpose just to see if you catch them. All right. Now this one, I promise I'm not going to make a mistake on purpose because it's a little bit tricky. When you're evaluating expressions, yes, PEMDAS still applies, but this one singular term needs to be simplified, and this one singular term needs to be simplified before you do any of the operation signs in between different terms. So I like to put different terms inside of brackets. So R, I'm going to replace with 6, and it's being squared. Okay, plus this singular term of 3 times R. Okay, and so this singular term simplifies to 36, and then this singular term simplifies to 18. And now I can take care of the sign between them. And you guys are like, well, Miss Love, I would have like multiplied 3 times 6 anyway first before adding, so why does this matter? Because what if the sign between here was a division sign? According to PEMDAS, you would have just gone left to right, and so you would have done this division here and then multiplied that number, right? Okay, because that's what PEMDAS indicates. But this is one singular term of 3R, and you're adding that whole term. So I need to simplify that term first, then you take care of the sign in between. So yes, I know it didn't really matter for this problem, but it could in the future. So please get in the habit of putting them inside of brackets for each term, and then simplifying each term, then taking care of the signs between them. Okay, and that final answer you should have gotten was 54. If you got all those right, congratulations. Those were pretty tricky. Okay, last page. You feeling up for the challenge? It says 10K times 4 times n minus 2. Okay, so I have this singular term out in front here of 10 times k. K is 3. Because when you're evaluating, that just means you're substituting in what k and n are equal to. Times, and this one, I have that whole thing inside of parentheses. N is 7 minus 2. Okay, so here brackets are kind of like its own parentheses, right? So I want to simplify inside of there. 10 minus 3 is 30. Okay, times, I still need to simplify inside of these parentheses. 7 minus 2 is 5. All right. Now for here, it's saying this sign is between this thing, right? So now I would go from left to right. So I could go 120 for these two guys multiplied together, because 30 times 4 is 120. And if you don't believe me, that's a 0. 4 times 3 is 12. It's 120. Okay, now bring down your 5. And now I can multiply those two. And 120 times 5, you get 0. 5 and 2 make 10. 5 and 1 make 5, plus 1 is 6. So your final answer is 600. And for this particular problem, it wouldn't have mattered if you did 4 times 5 is 20, and then 20 times 30, you still would have gotten 60, because commutative property, you could go 2 times 3 is 6, 6 times 2 is 12, or 2 times 3 is 6, 6 times 2 is 12, or 2 times 2 is 4, and 4 times 3 is still 12. You can move the numbers around when you're multiplying only, right? So it technically wouldn't have mattered, but again, if it was division, then that just changes everything. This one, you have 17, one singular term, plus, okay, let's focus on this term, is 5 times t, which is 1. Okay, minus this term, which is 10 to the 0 power. Okay, so let's simplify inside of these brackets. 5 times 1 is 5. And anything to the 0 power is 1. Okay, so I simplified those brackets, these brackets bring down your other number. And now you just have the operation signs between each individual term. And since they're only adding and subtracting, we go from left to right. 12 plus 1 is 22. Bring down that minus 1. And 22 minus 1 is 21. Okay, my next one. You have 3 times A is 5. Plus B is 4. Divided by that term is also a 4. Okay, so first I need to simplify this singular term, and I get 15 plus 4 divided by 4. Now all the terms are their own individual single numbers, right? So then we just take care of the signs between them following PEMDAS, and we do division before addition. So 4 divided by 4 is 1 plus 15. 15 plus 1 is 16. And to help me when I get to this step, I kind of go through PEMDAS each time to make sure that I don't forget to do this first. I ask myself, do you see any parentheses? No. Do you see any exponents? No. Do you see any multiplication or division? Yes, right here. And that reminds me to do this before adding. Okay, next one. You have the term of 12m, so I'm going to substitute in an m for 2. Divided by p, I'm going to substitute in a 6, plus m to the power of 1. Okay, so let's simplify inside of here. 12 times 2 is 24. And then simplify that exponent. 2 to the first power is just 2. There's 1, 2. Okay, now they're all each individual single terms, so follow PEMDAS. You divide before you add. 24 divided by 6 is 4, and 4 plus 2 is 6. Okay, and now back to mod 9. Let's do the prime factorization of 80. Okay, I would probably do 8 times 10. 8 can keep going to 2 and 4. 2 is prime, but 4 can keep going to 2 and 2. 10 is 2 times 5, prime, prime. Okay, so I'm done. They all ended in their little happy berries. We're done. You have 2s and you have 5s, but how many 2s? 1, 2, 3, 4 2s and a 5. Now some of you are freaking out. Oh my gosh, I missed it because I didn't do 8 times 10. It's okay, as long as you didn't make a math error, you still would have gotten it. Let's say you started with 2 times 40, prime. Right here, you could have done 4 times 10. That's 2 and 2, and 10 would give you 2 and 5. And look at that. You have 1, 2, 3, 4 2s and 1 5. And even from there, instead of doing 4 times 10, what if you did 2 times 20? And from 20, you could have broken it down to 2 and 10 or 4 and 5. Pick one. Okay, no matter which way you picked, you still would have gotten it. You guessed it, 1, 2, 3, 4 2s and 1 5. Okay, so as long as you don't make a math error, we still end with the same prime factorization. And finally, 65, it ends in a 5 or 0, so you know 5 can go into it. And let's see how many times 5 goes into 65. It goes into 6 once. Subtract, you get 1. Bring down the 5. 5 goes into 15 3 times. And it ends in 0. So you know that 5 times 13 is 65. And 13 is prime. So that's it. It's just 5 times 13. Okay, again, don't forget to find similar problems in your homework or notes to ones that you missed. So you can try those ones and star ones you want to ask for help. If you got them all right, congratulations. These were pretty difficult.